Okay, this is me. My job title is Senior Principal Design Engineer, about the longest job title you could go for. And currently, as Trish says, working for MAHLE Powertrain. And all I need to do is that one.
Next.
Okay, so similarly, I'm going to go through how I got into engineering, and then I've got a bit more on what MAHLE Powertrain are all about, and the history, as Trish mentioned, used to be Cosworth Engineering in the early days. I was brought up in France. I was born in France, and when I was 14, roughly your age, I thought, I don't know what I want to do at all. Didn't care. I loved languages. I loved maths. Hadn't done much physics at that stage. And then I thought to myself, I did my GCSEs and kept all the options open. I did French and German and English language, English literature, history, bit of maths, bits of physics, bit of chemistry. Left everything open. When it came to choosing A-level, I thought, if I do French and German, I'll probably end up a banker. That doesn't sound like much fun. I'll do physics and chemistry. Maths was a done deal. So I did my A-level maths, physics, chemistry, and further maths at the last minute. And then I had a similar experience. I said to my dad, I'm going to go to university and I'm going to do engineering. And he took one look at me and said, help! And then he went off and talked to people he knew at work, and he discovered, exactly as Sarah says, that actually engineering is a nice broad topic. And when I was doing my degree, about 30% of people who had an engineering degree ended up doing engineering. The other 70% went and did all sorts of things. Somebody went into theatre, somebody else went into accountancy. So it's such a broad degree that you can use it just to show that you have the ability to do science, you have the ability to do maths, and you have the ability to think and problem solve. I'll try this one. No, that's not working. I'll go with that one then.
It should work with the forward.
Try that one. So in 1989, showing my age now, I finished my degree. And I went around wondering what job to do, and I thought, which part of my degree did I love best? Well, I did an engines degree in my third year, and I loved it. There were 5 of us. It wasn't exactly the most popular course on the degree that you could take. There were 5 of us doing engines, but it was really fascinating. So I thought, that's it. I know what I want to do. I want to work in engines. And there aren't that many options in the world of engines. So I applied to Cosworth in Northampton. I applied to Perkins over in Peterborough, who make big diesel engines, and Ricardo down in Shoreham. Those are pretty much the big engineering consultancies in the UK. And actually, I went over to Perkins, and the lady who interviewed me told me, I'm not sure our senior engineers will cope with a girl engineer. So that was the end of that one. And years later, you think you should probably have taken them to court at that stage, but never mind. Thankfully, Cosworth weren't that short-sighted and offered me a job on their graduate training program, as I say, in 1989. From there, I went graduate training for 2 years, and then I got a job in 91 as a development engineer. I'm going to go through this quite quickly, and then we'll go back to what the different functions do. And from being a design engineer, I went into development engineer. I went into design, from design into R&D, and then back into design. And that's where I've been ever since, because I love it. So what are MAHLE Powertrain all about? It's an engineering and manufacturing services provider. I'll read that bit. Doing research, design, development, testing and production of high efficiency engines. The heritage is quite old. The heritage comes from 1958. 2 men, Mike Costin and Keith Duckworth, who forever should be everybody's heroes, started up this company because they wanted to do race engines. And in 1973, they thought, we can't find anybody who'll make our cylinder heads the way we want them, so they started a foundry over in Worcester. They moved to Northampton in the late 60s. And in the 1980s, they got into road engines, the sort of thing like the Sierra Cosworth. Those of you old enough to be car fanatics in the 80s, probably none of the junior members would remember the Sierra Cosworth when they used to show robbers being chased by police cars. The police cars were probably definitely Sierra Cosworths, and half of the robbers were as well. That was a sort of boy racer car of the time, and that's where Cosworth engineering started in road engines. In '98, we got bought out by Audi, and the road engines part became Cosworth Technology. And then in 2005, re-bought out by MAHLE, and I shall tell you a little bit about MAHLE in a minute, and became MAHLE Powertrain. Some of the interesting things that have happened since MAHLE down there, did an extreme downsizing engine, which is on the board back there, but I've got a picture in a minute. And then they made this car that you can see down there to take around Germany, showing to everybody, to show what a good thing it is to have a downsizing engine in there. This is MAHLE Powertrain. These are where our customers are. So unfortunately, don't go as far as space, but we have customers all through the world. So I've been to Korea, to Japan, to America, to lots to Germany, all around talking to people about what they want in an engine. And our main sites are Northampton, which is where I work, in that lovely building up there, Wellingborough and Worcester in the UK. We have an office in Stuttgart, and Detroit, and Brazil, and China, and Tokyo. And if I wanted, I could ask to be moved to any of those places, and off I'd go. I share with Sarah the desire to stay in the UK and have a young family and take them to English schools and not have to dash off to all parts of the world. But some of my colleagues do. Presume most of you go in buses or cars every day of your life. And these are some of the parts that are under the bonnet. How many people have ever looked under the bonnet of their parents' car? Something any of you do. And most of the parts of the engine are made by the MAHLE Group somewhere. The MAHLE Group is 50,000 people throughout the world. There's a few pictures of them. MAHLE Powertrain is split into 3 areas. The engineering is where I work, and that means that we do the design of the engine. It's, again, I keep referring to Sarah's presentation because what was astounding was how similar it is. Probably smaller budgets, probably rather quicker. It takes 4 to 5 years to get an engine signed off so that it can go into production. But very much the same principles. We sit around, we have meetings, we cost out how much it's going to cost to make a whole engine program, and a whole engine program is probably of the order of £20 million. Then we agree how big it's going to be, how many cylinders it's going to have, and we draw out a specification, and from that we do the design, and then we make all the parts, we build them, we test them, we calibrate them, which means we sort out the electronics so that the data goes from the engine and decides how much fuel to put in, when to put the spark in the engine, and that sort of stuff. And then we validate it and we take it into production. So that's the engineering part. Manufacturing, we have a factory over in Worcester, I showed you on the picture. We do aluminium blocks and heads. We do machining in Wellingborough, and we do assembly in Northampton, all the way from a few parts, a few parts to thousands of parts, probably sort of 20,000 parts. And finally, Test Systems is part of the Detroit office over in America. So the part I'm involved with is the design aspects. That means we do a lot of meetings, a lot of standing around. The picture in the top left are some of the guys I work with, or used to work with, looking at CAD terminals, looking at drawings, laying down the specification, drawing out every single part of the engine, getting it checked, getting it made. Down in the bottom left is a cylinder block for a V6 engine. That's actually an Audi block that I worked on in the early 2000s, I guess. Top right is a picture of the downsizing engine. That's a 3-cylinder engine that's currently out exploring the world. And then the bottom right picture shows you the sort of validation we start with. When it's something nice and down to earth like an engine, it's not too expensive to go and make a few parts. So we'll tend to do the first validation by computer. So that's an analysis of the water that's in a cylinder block and a head. And the red bits show where it's hot, and the blue bits show where it's cold at that particular stage. And we'll analyse that, and then we'll buy them in, build them up into an engine, and put them on a test bed. This is the manufacturing side of things. So the cylinder head that's in the engine in your car has probably been made by being cast. And the casting process is quite a clever one, really. You make pieces of sand, which is what's in the far left side. You make lots of different pieces of sand, and then you build them up like a big Meccano set. And then you pour in the aluminium, and you let it cool. You make sure it's full and it's not too airy, too bubbly. And then, hey presto, you've got yourself a casting. And down in the middle is a casting of a V12 Aston Martin cylinder block. You gather all of those pieces in a huge long list of parts, and you build it up into an engine, and that's our assembly line that's now in Northampton. The testing part of things. On the left-hand side is a test bed. You get a test engineer who sits there, who defines how much fuel, who takes all the measurements and defines what it will do. In the middle there is a cold chamber. So because your car has to be okay, if you were to go to Sweden or live in Sweden, and you want to make sure it's going to start of a morning, you don't want to be sitting there waiting for it to warm up in the middle of the day, we have to make sure that it'll cope with cold weather or hot weather. And we can't dash off to Sweden every 2 minutes, so we have a special chamber that cools it down or heats it up, and we leave it there for a little while until it's nice and cold, and then we test it in there to make sure it's all going to work. And then I rather like that picture. We also need to make sure that if you park your car on a steep hill, you'll be able to start it then as well. Or if you're going round a banked corner on a circuit, that will work. So that rig was designed specially to throw your engine off at different directions and run the engine at funny angles to make sure that it will always work. This is the latest downsizing demonstrator that we've been working on. It's a 3-cylinder technology demonstrator. It's a nice little picture of an engine, I think, more than going into the details of it. But everybody knows fuel is getting more and more expensive, so the real challenge for engineers at the moment is to get more performance out of a smaller engine using smaller emissions, and that's our answer to it, one of our answers to it. At the other end, that's the green end of the scale, and at the other end of the scale we always have customers who come to us and say, actually, you know, I've got this V8 engine, huge big engine in a posh car, and please can you make it more powerful, I want to have turbochargers on it. Because most people in the car industry are boy racers at heart, and so that's a V8 turbo engine that we did a few years ago, and a V10 demonstrator we did as well. And they all get very excited about the power curves of the engine, and that's what it's all about, is we get asked by our customers to produce a better power curve, which is that picture on the right, and off we go and tweak the engine until we achieve that. The other way of approaching the challenge of reducing fuel economy, of improving fuel economy, is to have a hybrid vehicle. That means that you have an engine but you also have a battery. Now, a completely electric car will run out of electricity quite soon. You have to plug it in, and you have to find places to plug it in. So if you were trying to get to Scotland, you probably wouldn't get all the way there before you need to stop and recharge your battery, which is quite slow. So the idea is to have an engine in your boot, or wherever, under the passenger seat, wherever, as small as you can, that you can top your battery up with when it's running low. And that's the latest R&D engine we've done is the range extender, which is a really small two-cylinder engine that you can install wherever you want in the car. And at the moment, that's what we're doing. We're putting it in a car so that will be the next car that we take around to show customers. So that's a bit about MAHLE Powertrain. Again, similarly to Sarah, it is nearly all men, but that's because that's who applies. At the moment, I'm involved with doing a lot of recruitment for the design department. I'm trying to recruit students, I'm trying to recruit graduates, I'm trying to recruit permanent people. Of the graduates that applied, so people who are just finishing their degrees this year, we had about 50 applicants. I think 2 were female. So there isn't much choice. One of them is being interviewed. We look at the CVs and they get shortlisted. And thankfully, they don't really much look at whether it was female or male. They just look at what the CV's like, how they're doing in their degree, how they did in their A-levels. The students, I'm after 5 student people, so people who are halfway through a degree. You can do 2 years of a degree, then a year out in industry, and then go back and finish your degree, which is a really good way of understanding whether that career is the one you want. And of those 40 CVs I've been reading, there isn't a single female applicant. At the moment in my company, there are, I'd guess, about 100 engineers. Of that, I'm the only female engineer around. I've got 7 people. I do the person leadership as well. I look after 7 people. I do have 2 female employees who report to me, only because my boss says, Tess, I don't know how to deal with females. You look after those. So I've got 5 engineers and an administrative person and a systems person who come under my name. But I don't think that should put you off. When I went to university, it was probably about 11% female population within it. But it never occurred to me before I went that women couldn't do engineering. It's about maths, it's about physics. I quite like those at school, so I just did it, and it's just not a problem. You can do it. As Sarah says, listen to yourself. If you enjoy it, do it. If you don't, don't. And certainly don't let anybody put you off it, because it's not I think mechanical engineering is seen as the dirty end. Well, I thought, I'll come to see you today in the clothes I normally wear to work. I don't get grubby. I go down the test cells. I go down the engine build shop. I can get grubby hands if I pick up a cylinder head and walk off with it, because I quite like doing that. But hands are easy to wash, and you can have tops. You don't have to be. You can choose what you want to do, and you can go more at the computing end, or you can go more at the manufacturing side. You can choose what you want to do, and it's really good fun. Thank you for your attention.